Yeah, so let's just quickly get started. Today we're going to talk about coronavirus with math. Okay. So first of all, welcome back to my YouTube channel. And then all you need to do is just search Ducks Education on YouTube, and then you can just subscribe here. There is a range of free videos for both year 11 and year 12, including how to maximize your data. That's my most popular video. So please make sure you go to the YouTube and then click the subscribe button, and then click the like button for the videos you like, and then leave a comment down below if you want. Okay. Yeah, so now let's start some calculations with coronavirus. Okay, so we all know, okay, it doesn't matter which country it is, coronavirus follows exponential curve. And this exponential curve is exactly the same as our geometric sequence we talked about before. Okay. So before we move on to the actual calculations, let's have a look at some basic knowledge. Okay. This is called the basic reproduction number. Okay. So the basic reproduction number is called R0. Okay. So R0 has three cases. So when R0 is less than 0, let's just say when R0 equals to half. Okay. So basic reproduction number is a number of reproduction without any controls. Okay, without any social distancing, without any controls. Let's just let the virus spread freely. And then how many people on average will be infected by each person is called the reproduction number. So the basic reproduction number equals to half means 2 persons will only spread this virus to 1 person. Okay, only 1 person will get infected. So it just becomes half person, 0.25 person, and a quarter person, etc., etc., etc. And eventually the entire virus will just vanish. Okay, the virus won't be there anymore. So that's when the basic reproduction number equals to less than 1. And now when the basic reproduction number equals to 1, we call it endemic. Okay, so what that means is I spread this virus to person A, and then person A spread this virus to person B, and then person B spread this virus to person C. It's always going to go in there, but it's not going to cause any further spread. Okay. So this kind of spread we call endemic. And then the worst case is when the basic reproduction number larger than 1, and then we'll call it epidemic. Okay. Yeah. And then for coronavirus, the basic reproduction R number equals to 3. Okay. It just means on average, 1 person can spread to 3 different persons. Okay. And then let's just going to have a look at without any controls, how long it will take to spread the entire Australia. Okay, we all know the total population of Australia is 25 million persons. Okay. So let's just based on this figure to do some calculations. Okay. So first of all, we need to introduce a definition which is called the generation. Okay. I keep telling everyone in the tutor, the coronavirus has an incubation period. Incubation period lasts to maximum 2 weeks, okay, which is 14 days. Yeah, but not everyone will have like a 14 days incubation period. Some person will directly show their symptoms. Some person will show their symptoms after 14 days. So based on the research, the general incubation period is roughly 8 days. Okay, so this on average, the person won't have any symptoms for 8 days, and then after all, it will show symptoms like I draw here. Okay, you guys see the box. Box means after the incubation period, the person shows the symptoms. Okay? But doesn't mean the person will spread the virus when it shows the symptoms. During the incubation period, it will also spread to other people. That's why this virus is so deadly and so harmful. Okay? Yeah, and then let's just say, so the red circle means person A, okay? And then the black circle means person B. So A has its so A gets the virus, okay? It's asymptomatic, so it doesn't show any symptoms, okay? He is just going around freely, and then he meet B, okay, during his incubation period, and then he spread the virus to B, okay? And then B, yeah, also has 8 days incubation period, and then after 8 days of incubation period, B shows symptoms, okay, yeah. So let's draw the first brown line. That's when A shows symptoms, and then the second purple line, that's when person B shows the symptoms. Okay, so the time difference between these 2 symptoms is called the generation. Okay, so on average, it's a 5 days generation. Okay, each generation is 5 days. So it takes 5 days to spread to the next person, takes 5 days to spread to the next person. Okay. We just need to remember this. Okay. Now let's do the calculations. Okay. So let's just think about it. From generation 1 to generation n, how many people are going to spread in total? Okay. So the first generation, just like the person who initially caught the virus, that's just one person. The second generation, it will be 3 person. Remember we said R0 values for coronavirus equals to 3, okay? And then the third generation will just be 3 multiplied by 3 because each person will spread to another 3 person, okay? So 3 multiplied by 3. And then our last generation, generation n, based on geometric sequence AN formula, remember? UN equals to A multiplied by R to the power of n minus 1. So the last generation, which is nth generation, equals to 3 to the power of n minus 1. And then if we just substitute these entire numbers into the geometric sequence formula, okay, which is Sn equals to A 1 minus R to the power of n divided by 1 minus R. I hope you guys all remember this formula by now. So plug it all in and then simplify it, we get 3 to the power of n minus 1 all divided by 2. Okay. Yeah, and then we also remember the entire Australia population is 25 million, okay, which is 2.5 by 10 to the power of 7. Okay. Bring 2 to the other side and then plus 1 to the other side. And then we just use a log 3, right? Take a log 3 on both sides. Or you can just use n solve in your calculator. Okay, it doesn't really matter what you do. And then you get n equals to 16. Okay, so it means so it takes 16 generations, 16 generations to spread around the entire country without any social distancing. Okay? And I will also know it's 5 days per generation. So overall, it will take 80 days. If we don't do anything, after 80 days, the entire Australia, every person will caught by coronavirus. That's why we have so many strict measures. Everyone's still staying home. It's just because of this. Okay? Just based on mathematical calculations, we find out, okay, after 80 days without any controls, everyone will get caught by coronavirus. So that is the first thing. Okay. Now the second topic I want to go through is the toilet paper. And then let's just quickly watch the video first.
Bankstown mother.
And if you guys can hear the sound and also see the video moving, could you please type a 2 to the Zoom group chat? I just need to make sure it's working. Okay. Cool. Yeah, let's start watching the video.
And daughter have been charged after a fight over toilet paper in Woolworths. The vision of the shoppers arguing with another woman went viral as supermarkets impose new purchase limits to curb coronavirus hysteria.
The fight over toilet paper that went viral around the world.
I just want one pack. No, not one pack.
Now the 60-year-old mother and her 23-year-old daughter, who were wheeling a trolley full of rolls at Woolworths Chullora, have been charged with a fray and are due in court next month.
I cannot understand the logic. We have a big factory in Penrith that produces toilet paper.
Investigators spoke to the other woman, a 49-year-old, who'd allegedly been assaulted, but she wasn't injured. The incident, one of several at Australian supermarkets, as desperation for toilet paper reaches irrational levels.
Everybody please stay calm and be rational. We have everything we need.
For the second time in a week, Woolworths and Coles have been forced to crack down on the number of toilet paper packs allowed to be purchased. At Woolies, customers are now limited to just 2. But here at Coles, it's down to just 1 per person. We have asked our suppliers to focus on increasing production of larger pack sizes. A pack of 30 rolls should last an average family for around 3 weeks.
We can all get enough toilet paper if we all calm down a little bit.
Hannah Sinclair, 9 News.
A Bankstown mother.
Okay, so that's the first thing. Okay, so for example, many places, including Canberra, and then people flooded into the supermarket and then stock up their daily necessities. Okay, especially the toilet paper. So for example, I live in Walden. Okay, so there's no toilet paper near the Walden shopping center for the entire month. Okay? So today we're just going to discuss how long the toilet paper will last. And also we know nowadays toilet paper actually worth a lot of money. Okay? That's watching the second video.
Can I just get a cheeseburger meal with the water? How much was it? $7.05. $7.05. 1, 2, 3, 7. Thank you. Was I short? There's $1. Keep the change. I just had to make a deposit. I haven't counted it, but there's quite a bit here. Yeah. Just straight hundreds will do. What's that? Just $100 notes will be fine. Just cashing in the toilet paper. Do you not do that bit? Oh, sorry.
Okay, yeah. So we all know the toilet paper worth a lot of money as well. Okay. So today we're just going to do some calculations. First of all, to see and the toilet paper you guys stocked at home, how long it will last. Okay, and then also we can calculate. Remember, 2 pieces of toilet paper worth $1. Okay, and let's try to see how much money you have at your house just based on your toilet paper stock. Okay. Yeah. So now let's have a look at our first topic. I hope, yeah. How long your toilet paper will last. Okay, yeah. And toilet paper questions will be another topic. Toilet paper, coronavirus spreading is geometric sequence with exponential functions. Okay, and our toilet paper is our arithmetic sequence. Okay, let's have a look at why the toilet paper question is arithmetic sequence question. Yeah. So first of all, I provide like different brands. Can everyone type into the Zoom group chat which is your favorite brand? Okay, which brand do you usually use at home? You're probably using a different one. You're probably using a different one, but those are the 4 most popular ones I see in the supermarket. Okay. Yeah. Yeah. I like Quilton one the most. Okay, the first one. Yeah, so let's just take a look at the first one. Okay, which is my favorite. Which is my favorite. Okay. So what we're going to do is we're just going to unroll the toilet paper and then calculate the length of the toilet paper. Yeah. So when we unroll the toilet paper, yeah, I just draw a picture here with the toilet paper rolled out. Okay. So when you unroll the entire toilet paper, it will just be infinitely long. It's like not infinitely long, but super long, okay, piece of paper. And then the width will just be this width here, and then the length will just be mega long. And then the thickness of each paper will call the T. Okay, the thickness I draw it in orange in the second picture. You guys can visualize it here. Okay, the thickness is T. Yeah. It's very thin, but it will still have thickness, so it is called the T. And then now let's have a look at what measurement we need to do. Okay, yeah, to do the calculations. Yeah. First of all, this is a toilet paper. And I need to measure the outer diameter divided by 2 will be my big R. And I need to measure my inner diameter. This is very easy to do with a ruler at your house, okay? And you can also measure your inner diameter and then divide by 2 will be the inner radius, we'll call the little r, okay? We'll keep these 2 notations throughout the calculations. Outer diameter is big R, inner diameter is little r, okay? Yeah. And then the thickness I just draw it in the picture. Second picture, I'm not sure if you guys can see it clearly, but the thickness of toilet paper is the total thickness will just be the capital R minus the lowercase r. Okay, that's the total thickness. Yeah. And then we can measure the individual thickness. Okay. Yeah. We can measure the individual thickness, which is in the third picture I draw here, this T. Okay. The thickness of each individual toilet paper we call the T. Okay. So this T we draw in this page is exactly the same as my orange shaded area thickness T when the toilet paper is rolled out. So we finish all the measurement, and then now remember we know the big R, the small r, we know the thickness. Now let's do the calculations. Okay. So I draw a front view or a top view for the toilet papers, and then let's look at each layer. Okay. So remember the thick black, that's not your toilet paper, that's just a rag. Okay. You can't use the black one, and then the first green layer, that's our first layer. Okay, so the inner diameter is R, and then the thickness is T. Yeah. So the total length for the first layer, which is the perimeter of that green circle, which is 2 pi R plus T. It is the circumference of the circle, which is 2 pi R plus T. That's our first layer. And then if we look at our second layer, which is our orange circle. Okay. You can see it's from R and then plus 2 of the thickness. Okay. So the length of the second orange layer equals 2 pi r plus 2t. And then if we have look at our last layer will just have a total length of capital R. Okay, so P will just equals to 2 pi R. And then let's calculate the number of layers. So how many layers are there in total? Let's do the calculations. Okay. So let's just let n equals to 10 total number of layers. And then we know for arithmetic sequence, the last term un equals to a plus n minus 1d. So our last layers are, our first layer is not little r, remember it's r plus the thickness, and then plus n minus t. The common difference of that arithmetic sequence will just be the thickness of each layer. Okay, that's just t. And then let's do the calculation and then rearrange, make r the subject. Make n the subject. N equals to r minus r divided by t. And then now let's calculate the total length of the toilet paper. Okay. So total length, you just add all the layers together, first layer plus second layer plus the last layer. I'll come back to that in a second. Okay. Yeah. If you have any questions, please stay until the end and ask. So our total length L equals the first layer plus the second layer plus until the last layer. Okay. And then you can see every single term has a common factor of 2 pi. So what I'm going to do is I'll just take 2 pi out. Come on. Oops. Okay, take 2 pi out. And then once we take 2 pi out, okay, everything inside, you can see it follows a perfect arithmetic sequence. Okay, r plus t, r plus 2t, r plus 3t, until our last term. Okay, between term and term, you add a new t. Okay, so you add a common difference t each time. This follows a perfect geometric arithmetic sequence. And we know the sum for arithmetic sequence is number of terms divided by 2 multiplied by the first term plus last term. Our first term, let me just draw it over here. So our first term is this one here, r plus t, and our last term is just our r. And then the number of terms is just the number of terms we get from the previous page, right? Yeah, and now we're just going to substitute everything in. Come on. Yeah, when we substitute everything in, and then we'll just get this length formula. You can see now our length formula is only in terms of the 3 variables we measure, capital R, little r, and the thickness of the toilet paper T. And then you can just based on your measurement or whatever the value they give it to you in the exams, substitute everything in. And then when you do the calculations, you'll find the length of the toilet paper is roughly 35 meters on average. Okay. Yeah, so that's the total length calculations. Yeah. Now let's have a look at the world ranking. Okay, so I go to the most reliable website and then find the toilet paper consumptions. Okay, so this is just a ranking. The first one is USA, and then Germany, United Kingdom, Japan, and Australia ranked number 5. Okay, so USA leads the world again with 141 rolls per person per year. Okay, and Australia ranked number 5 with 88 rolls per person per year. Okay, what does this mean? Remember, we just did the calculations. We find each roll is 35 meters. Okay, let's do the calculations. We have 131 rows. Each row is 35 meters. Divided by 365 days, and we get USA person. Okay, they used 34 meters per day per person. Okay, yeah, no wonder they eat a lot. Okay, they eat a lot and then they use a lot of toilet paper, so they use 34 meters of toilet paper per day. And then in Australia, okay, we used like roughly half, so we used 17 meters per day per person. Okay. So if you use less than 17 meters per day, congratulations, you are saving the environment. You are also like saving the toilet paper for Australia. Okay. Yeah. Okay. And then, believe it or not, there are 4 billion people. Okay, 4 billion. Okay, not million. There are 4 billion people in the world. They don't even use toilet paper. Some of them might due to financial reasons where they just can't afford toilet papers. Okay? And then some others might due to their traditions, and then their traditions just don't allow them to use toilet papers. And then there are 2 billion people, okay, in the world, which is the poorest people. They don't even have a fixed toilet. Okay? So we're still very lucky to be able to have, we can like go rush into the supermarket and then shop for the toilet papers, okay, and then we can use the toilet papers. So please cherish whatever we have now, because we're very, very lucky. Okay? And then just as a summary, let's just go through my toilet paper summary. So our life, okay, I think our life is just like a roll of toilet papers. Why our life is like a roll of toilet papers is, if you think about it, at the first, the toilet paper is very thick. So no matter how much you use it, it still remains a lot, okay? But when it is about to finish, just one more piece teared off, the entire roll is over. So you don't cherish what you have until it is gone. So please, we should treat our toilet papers as our lives and treat it and then cherish it every single time we use the toilet paper. And then last but not the least, I hope you make your life like the toilet paper very long and then very useful.